noise removal. And now let's go to the next one, calibrations. So we go to Radiometrics and calibrate, and use the source. The source one is the latest one, the latest image after we process the thermal noise removal. So okay, we need to set the directory.
This is the study area in Pahang or somewhere else?
In Selangor. In Selangor.
Okay.
After that, we run the image. Okay, after we run the image for the previous image, we no need them, so we can just close the product and then display. So as we can see, is in the form of sigma 0 and VH, because now we are doing the conversions to the backscatter, to conversions of the raw data into the backscatter coefficients. Okay. Yeah, actually, this kind is all the calculations. But if we run in NV, you need to do the bandmath and calculate using the formula. But this menu is quite waste some time. So after we do the calibrations, we will go to the next pre-processing, which is radiometric terrain flattening. The reason to do the sum of the radiometric terrain flattening is we need to eliminate some noise from the terrain side. Okay, so we just go here and as set the directory in the same place and click run. Okay, as at this sense, just a moment, choose these two bands by linear interpolations. Okay. Okay, just click run. It lets us, yeah, there are some parts, lets us reverse our process. Um, Let's just reverse for the process for this calibrate, because for the calibrate we need to choose beta 0 instead. Okay. We need to choose the or select the beta 0 band. In the calibrations. So in the beta 0 we can proceed to our radiometric terrain flattening process and choose these two with suspend run. Okay, for the previous one, we need to close it, the previous product. Okay, we can see here, later on, perhaps you can try other resampling methods because there are some of the error I think during the interpolations when processing the resampling method. So let's proceed to the next. Okay, now we need to do multi-looking the and also speckle filter. For this multi-looking, we need to go to radar and star utility and click multi-looking. And thus the same, we need to set create our directory and it show ml multi-looking. So this is also one kind of the algorithm to reduce the standard deviations of the noise level um, in the SAR image. So we just run that. After we process the multi-looking, we can go to the next one is to do some filtering, speckle filter in the radar. So you go to speckle filtering and choose single product speckle filter. So the function of the speckle filter is to eliminate some of the granular noise that uh, stay in the radar image. So we want to eliminate some of the, as you can see, some of the granular noise in the image, so that to make it more clearer for the processing later. And in this filtering, there are several types of the filters. I choose Lee Sigma, and later on you can choose the other filter and see the effect after you run the classification, whether there's um, there's a difference or not. ml. Okay, so it's ready, and we need to close the product. Okay, okay, you can see the effect before the speckle filtering, before we are running the speckle filtering, and after the speckle filtering. So obviously the the filtering which we select Lee filter has improved the quality of the radar image by removing the granular noise in the SAR image. So now let's go to the next one. We need to do the geometric corrections. Okay, what type of the geometric corrections? Okay. So now, as as we need to know that our study area might have uh, different terrains, so they will have some of the error when the backscatter signal reflected back to to the the sensor. So they will be have some of the uh, geometric geometric error, and now we need to run the or process the geometric corrections in this scenario. So we need to choose the range Doppler terrain corrections. After that, okay, so for the map projections, since it is linked to the geometric corrections that to adjust some of the coordinate based on the terrain arrow that uh, attributed contribute to this arrow. So we need to always adjust the coordinate to the standard one. So, but in this practical, I will select WGS 84 as a standard. So we can run that now. Okay, let me see that. Yeah, the band is VH. Okay, I think in the process just now I didn't I make some mistake. It's okay. DF ML. Okay, because we need when we are processing, we need to ensure that this VHVV is inside here, because just now I think I missed something there. So we need to ensure when processing parameters is have we have the VH and VV, so that so generally it will be having VH and VV. these two. And now we can assign, because now our image is in the form of gray, we can assign the RGB combinations, or the simulated RGB bands based on the VH and VB.
This is a forest area or urban area?
They are more urban area than the vegetation, but lesser forest, not not so many forests. So it's urban area. Just a moment.
At the moment, if the students are using QGIS, Quantum GIS, in Quantum GIS, we didn't have proper plugin for radar processing. Am I right, Yuhao? For radar in QGIS, there is no proper plugin, isn't it?
Yeah, not proper yet, but I need to recheck back.
Yeah. At the moment, Snap is very good because it was designed, this software called Snap that Yuhao is using. This one was designed specifically for the Sentinel-1 processing.
Yeah.
For civil engineering application, when we talk about radar, actually there are two types of radar. One is the airborne and satellite-based radar. Another one is the ground penetrating radar. Maybe for for environmental investigation, it is good to use the satellite or airborne radar. But for more specific, more detailed infrastructure kind of mapping in the industry, they will use the engineers, the surveyors. Let's say, for example, they want to detect utility pipelines. They want to detect the conditions of the soil or the formation underneath. Normally, they will use the ground penetrating radar, the GPR. Yeah, so there are two types of radar. Normally, they will use in real application. So the one that we are using at the moment is the imaging radar, okay, from satellite or airborne. Okay, but in civil engineering application, you will see a lot of the GPR. Okay. Okay, you all.
Yeah. Okay. So, um, okay. So now we want to assign the RGB image combinations rather than seeing it's black or white in the form of black or white color. We can just assigning red for this VH, green for VV, and blue we can choose either VH instead. And you can see it has appeared in the simulated RGB image form based on the VH and VB. And now, okay, now we still have 6 minutes, and now we we need to do the classification, right? As earlier, as I showed earlier from the previous sessions, we when we run the classifications in the Sentinel-2, we need to collect the ground truth, and to collect the ground truth, we from this radar image we cannot do the in a proper way. We cannot collect the ground truth using this SAR image. So we need some assistance from the Sentinel-2 optical image, so that if we do the near infrared combination, we can easily collect the ground truth. So so you guys, it is better when you process, when you want to collect the ground truth for the star image, it's better to have another set of the Sentinel-2 for the purpose to collect the ground truth. Since I already collect the ground truth, so I will just import them because this ground truth was collected from the Sentinel-2. So I will import the ground truth to do the classifications. So on. Okay. Okay, you can see if the ground truth has been collected. In this ground truth is consists of two vegetations and urban. And now we can proceed to the classification for the analysis. And there are several algorithms here in the Snap software to process. The algorithm are random forest classifier, KNN, KD3, KNN maximum likelihood, maximum distance, or speckle angle mapper. So in this sense, I choose random forest classifier, and we need to import the product, but since it's already in the Snap, so the product image we just add open, just click add open. After that, okay, after that, for this training vector, we need to choose vegetations and urban because it has represent the rest. And for the feature bands, we need to select VH and VV. And for this hyperparameter, you can tune it manually later on after that. And after that, the product, we need to save it RF2. So, okay, so it has been saved in my directory. So after all has been okay, so we can click to do the classification. We can click run to do the classification. Just a moment. So this is some of the report and also the accuracy. Okay. Okay. So after the process has completed, you just close it and close the product. And this is the product. Let's open. Okay. Yeah, this is the product, and you can save the product as TIFF file. Okay, you can save the product in the TIFF file later on, and show it in display in the QGIS. And this is the classified image between the urban and the default. Just one. Let me open it in the QGIS because we already have the product. So now we can open in the QGIS for the last one. Okay, so this is our. We can change the.
Okay, now it's 12, Yuhao.
Yeah. Okay, so this is. Okay, so this is the product. So the green is vegetation, the red is the urban area. So basically, I have shown how to process the radar and do the classifications for this radar image. I think that's all from me for today. Okay, okay, doctor, I have done.
Okay, thank you very much, Yuhao. Okay, so just to conclude of what we have done today. Okay, so basically today we have covered uh, LiDAR and radar processing. Okay, so we have finished on the remote sensing part, and also we have discussed about test 2. Okay, so you have formed the groups, and also you have suggested the topics that you want to work on. Okay, that's good. For those who are yet to finalize the topics, please let me know as soon as possible. All right, so that you can start working on this test immediately. Okay, because you need to compile the information, you need to find the data, you need to process. Okay, and then you need to prepare the slides and everything. Okay, so it will be an oral presentation later on. Okay, so you have any questions before we stop? Okay, and also I have posted the first practical assignment, okay, for you to complete. Okay, and practical 2 will be posted later on Putra Blast. Okay, on Putra Blast, I have put the information about test 2 and also information about practical 1. Okay, practical 1 that you need to do and submit the report. And also you have previously the assignment. Yeah, the assignment, I think you're supposed to submit, when was that? I forgot already. I gave you the assignment very early. You still remember when is the deadline? I think around this time, isn't it? I have to check again. You remember, Yuhao? Assignment 1.
I think it's before a year.
Yes. I think it's before a year. I think you're supposed to submit that. Okay, so have you done so? You haven't done it? If you haven't done it, you can try to finish off within a week, okay? And email to me your assignment as soon as possible. Okay, so if you don't have any further questions, we can stop here for today. Okay, and I'll see you again next week then.
Doctor,
Okay, thank you very much. Thank you, Yuhao. Okay, thank you, everyone.
Doctor, may I ask, for assignment 1, we need to email or just submit in Putra Blast?
You can email me, or you can also use Putra Blast. But just in case, you just do both, okay?
All right, Doctor, thank you.
Right. Okay, so thank you very much.
Alright, thank you, Dada.
Okay,
Thank you,
have a
Doctor.
good day. Okay, Assalamualaikum and thank you.